Ever wondered how the science officer on board that spaceship on your favorite TV show knows how many life forms there are on that other planet? Maybe the USS Enterprise is already using 6G. Hello, I'm Michael Hainsworth. We've barely just scratched the surface on 5G, and the next generation technology is already being advanced by the people at Nokia Bell Labs. You know, the folks that invented the transistor in 1947, gave us the laser in 1960, and in 1972 introduced the C programming language to the world, the language the world overwhelmingly uses today. This is Peter Vetter. He is the president of Bell Labs Core Research. It's his job to make 6G more than just another G. And while we may not notice the power of 6G on the street, he's going to change the way we work and live.
What I see happening 5 years from now is a increased digital-physical fusion, the fusion of digital and physical worlds. And that will allow us to have a better understanding of what's happening in the physical world, and then anticipate possible needs and augment human capabilities.
On this episode of The Network Effect, we'll learn why we need to upgrade to 6G, who benefits, and if we'll ever see the technology in the final frontier. Give me an example of how 6G might work in areas where we never expected it before. Just the idea that you're monitoring how wireless interacts with its environment is fascinating.
Yeah, so one new capability that we are exploring with 6G is the opportunity to not only communicate or use the radio channel for communication, but also use it as a sensor. We're familiar with radar. At airports, you can detect airplanes arriving. It can be used for speed detection. Hope you didn't get a speeding ticket. So that these are radar technologies. But the thing is, you can actually reuse the radio base stations that will be all around us also as a sensor using that radar principle, and do that in a way that you don't impair the quality of the communication at the same time.
So you don't necessarily have to use expensive technologies like LiDAR or radar, since you would already have 6G in a factory or down the side of a highway.
So that's indeed the idea. Reuse sensors, so to speak, radio-based, that are already installed there.
You conducted groundbreaking research on 6G connected to artificial intelligence. What are your favorite proof of concepts?
So since you mentioned artificial intelligence, one favorite proof of concept is really how we have shown what AI can do for the network and what AI can do for the radio communication. So AI can automate our network, and we have shown how you can even use natural language models to translate human intentions through an application programming interface into something that a network can understand. And then we have also used natural language models to automate the service generation. We have shown how you can have specifications of network functions that are written by humans, make them understand by AI through natural language models, and let them figure out how they can be stitched together in an end-to-end automated service generation. So this is something we have shown end of last year. And another thing, even a step further, AI over the radio air interface. The base station, the handset, both having AI algorithms and just figuring out how to communicate in the most optimal way. And we have demonstrated for real that you can actually improve the capacity like 30% compared to classical approach. So I'm really excited about these capabilities of AI and what that can mean for the network.
You're also working with NTT and Docomo and SKT in South Korea?
So indeed, to make progress in 6G, it's important that we collaborate with partners. Our customers like communications service providers like NTT in Japan and Docomo, and then SKT in Korea. Indeed, as you mentioned, what we do with them is evaluate what AI can do for the radio air interface. So they're actually evaluating now our proof of concept on AI over the radio interface that I mentioned earlier. The other partnership that I want to mention is our collaboration with Bosch, where we are evaluating the radio sensing and joint communication. So we have a first proof of concept to show that this can be done for real with a standard radio base station, a millimeter wave system. And we're currently testing that in Arena 2036 in Stuttgart. This is an experimental factory where we collaborate with the industry partners like the company Bosch, and they're really evaluating it in a factory environment and also looking into new use cases like safety.
Yeah, well, we spoke to Clemens Ackermann over at Arena 2036 in Germany. He was super excited about the value of 6G in automotive development. And I love the idea that the autonomous robots could use wireless to detect workers in its path without all of that additional gear.
Yeah, indeed, that is one of the use cases. So we already started in 5G localizing robots using 5G signals and through some algorithms get a fairly accurate position of 1 to say 1 meter or 1 foot even accuracy. But this still requires that you have the radio signal connecting with the robot. Now with the radar, you can do a lot more. You can actually, you're not relying on the radio signal only. You can even detect some shape. You can detect also speed, movement of chest, heartbeat. So it gets, okay, I'm sensing a human or a mammal. I see a rotating fan. Oh, that must be a piece of equipment. So this, with add AI to that, there's quite a lot that you can sense there.
Wait, so back up. You're telling me that 6G has the ability to tell when I'm inhaling my breath and exhaling? It's that sensitive?
Yeah, indeed. Yeah. So I'm not saying that this is going to be medical grade measurement of heartbeats, but you can get to first order. Okay, everything is okay if it's monitoring an accident, for instance, or just identification. What is the object that we're seeing? It's a human. It's a mammal. Yeah.
This feels like Star Trek when they say no life forms on board, and you're like, how can they sense that? Or they say, yes, there are 12 life forms on board, and you say, well, wait a minute, how do they know that there are so many people on that ship? Maybe they're using 6G in a galaxy far, far away, or sometime in the future in Star Trek.
Well, science fiction is often a source of inspiration, right, for making things real. I mean, the communicator in Star Trek, and then they had this device of medical analysis. Or we're getting close to that.
If I recall correctly, just the idea of a cell phone, the very first cell phone, got its start because of Star Trek. And you even got one on you.
Yeah, so indeed, today we have these 4G and 5G phones, but I actually happen to hear a 1G with me. The invention of cellular networks happened here at Bell Labs in New Jersey. It was in 1947, the same year as the transistor. And then it still took some time to get to 1G, the analog phone that I just had here. And then in the 90s, we got the rise of digital phone with the rise of the Nokia handsets. And then our industry basically turned out a new generation of networks every decade. That seems to be a returning constant. And about every decade, you want to reevaluate technical capabilities in terms of semiconductor, new insights in radio, new software technologies like cloud-native design, and then also new use cases.
Beyond faster speeds, 6G leveraging AI will transform base stations into sensing devices, capable of detecting human presence and movements on everything from a factory floor to an office building. That enhances safety and efficiency. The partnerships with NTT and Docomo, SKT, and the industrial giant Bosch will prove that the concepts in the lab actually work out here in the real world. We can only begin to understand the power of a 6G sensor that can detect human breathing, but we need to do this by investing in new spectrum and technologies. 6G will introduce new spectrum bands along with the energy-efficient equipment and advanced AI capabilities to handle this exponential growth in data traffic. But why work on what's next when we've barely scratched the surface on 5G?
Yeah, so indeed there is a bit of a concern in the industry. We still struggle in monetizing the 5G. Will we really need the capacity in 6G? Redefining the network architecture is an opportunity to also tap into more value creation with the network. But let me explain that a bit. So today, AI and cloud, everybody agrees that this is reshaping our digital economy. And everybody agrees there's a lot of value in there. But there is actually a third important pillar, that is the network. The network is central to that digital future economy because it connects humans and devices with the AI capabilities, the data analytics, the cloud that provides the processing and enables the new applications, and feed that information then back to humans for consumption and for industrial automation. So there's an opportunity to redesign the network architecture so that you can tap better into that value of the future digital economy.
It must be incredibly frustrating that we haven't fully monetized 5G yet, and so there are calls to slow the development of 6G.
Yeah, so I think this is just a phase. We see that in 4G as well. 4G, it's good. LTE, do we really need 5G? But I would say today, thank God we invested in 5G, because we would have lack of capacity and bandwidth if we only rely on 4G. Same will be true for 6G. I mean, it's a macroscopic law. Capacity increases every decade by a factor of 10x approximately. And so by 2030, Bell Labs consulting analysis actually has shown that the 5G network will run out of steam. So we need new spectrum, 6G. And when you install new equipment for new spectrum, you want to do that in an energy efficient way with the latest and greatest technology. You cannot allow that when traffic goes up by 10x, that the power consumption goes up by 10x. In fact, we have pledged that power consumption should go down by 50%. So you want more energy efficient technologies. I'll like to make the comparison with buying a car. After 10 years, on average, a family buys a new car. You then don't buy an old smear diesel. You buy now an EV or a hybrid. Same thing in networks. You want the latest and greatest energy efficient technology so that you install capacity that will enable you to continue to support your services.
So what are the technologies required to realize the exponential potential of 6G?
Every generation is defined by new spectrum, a new technology, a new architecture, and a new capability. So, new spectrum. In 5G, that was first hailed to be millimeter wave. That turned out not to be the right frequency range, but mid-band, around 3.5 gigahertz and C-band. So that was the success in 5G. And now for 6G, we're looking at a frequency band just above the current mid-band, 7 to 8.4, and then up to 15 gigahertz. So that's the new spectrum technology, and that's an important frequency range because it allows to create coverage from existing cell sites. The new technology. Everybody agrees that AI is the new technology for 6G. Yes, there's a lot of things that you can already do in 5G, but there are also limitations. So creating a new framework so that you can allow for innovations for a decade to come in the radio interface, as well as in the network automation, is an important second new technology. And everybody agrees it's good to have a new spec that you're not limited with the incumbent approach. Then the new architecture, I think, preparing for the API economy, the application programming interfaces, so that we can treat the network more as a platform and enable new applications, new business models, that application developers, service providers, industries can use that infrastructure in an integrated way with the cloud and AI. So that is the new architecture that we're going after. And 5G already made a first step by embracing cloud. So the new architecture in 5G has been the cloudification of the core, as we call it. And that is an important step, and we see an evolution going forward into 6G and then really opening it up for new business models. And then fourth, the new capability. And the new capability in 6G that we're exploring is that sensing, that joint communication and sensing.
We've seen what happens when we give people new tools to build new things. The transistor made radio portable for young people, and rock and roll took off. Advances in satellites made GPS wayfinding possible. And LEDs made it possible to build massive screens. For software, an application programming interface is just such a tool. Imagine developers being able to drag and drop 6G functionality into their apps without having to write a single line of code. That's coming. Venner points out that 6G will treat the network as a platform, creating new business models and applications through an API-driven architecture that integrates seamlessly with the cloud and artificial intelligence. But the only way to make this vision a reality is through the network effect. Venner's Nokia Bell Labs is leading the Hexa X2 project, uniting 44 competitors and academic partners to develop a common blueprint for 6G.
It's bringing together indeed different players in the industry, communication service providers, system vendors, component vendors, industry verticals, and then a significant size also of academic partners to progress 6G. And yes, you're right, some of them are competing, but actually we have a common interest here. That is to progress 6G, to agree and pre-align on a common blueprint for the 6G architecture, is kind of pre-standardization research, to investigate possible use cases, to do research on enabling technologies. And since we're now in the second phase, we are also looking into more end-to-end system proof of concepts to show the value of 6G.
I suppose at the end of the day, for competition to exist, you need a level playing field, and everybody needs to know what the rules are to the game. And I suppose for you, that's called standardization.
Indeed, standardization is essential in our ecosystem. You want that interoperability between your handset or future other devices with any base stations. And that can be here in New Jersey, in the US, but when I step out of a plane, my handset works also in Europe. Standardization is also important to actually then have the volumes, the economies of scale, so to get it really into an affordable solution. It's also a mechanism to capture the requirements. Increasingly, as part of the standardization, we have also industry players and verticals that share their requirements. And this is maybe a good point to mention that we're actually transitioning in the 6G. We're no longer just in the research phase. I mean, Bell Labs, we started the research 5 years ago, but we are actually starting with the standardization this year. And you need that timeline to get ready by 2028. That is the understanding of having the first 6G release specification, so that we have then commercial deployments by 2030.
So what barriers do you still need to clear to make 6G a reality?
Indeed, standardization is one of them, but then we also need to secure the proper spectrum. And we actually, end of last year, achieved an important milestone in the industry at the World Radio Conference. It was agreed that the upper mid-band of 7 to 8.4 and then higher up to 15 gigahertz are important bands for 6G, so that we have that higher capacity. And now we need to go through the processes to, on one hand, prove the radio capacity on those and technologies on those frequency bands, but then also convince the governments to free up these bands. I think that is an important barrier to overcome. And then it's also moving from the lab proof of concept, where we put the finger still on the solder joint, to more reliable prototypes and test them out also in the field. And just as an example, we as Nokia have actually realized a first massive MIMO 6G radio system in that new frequency range of 7 to 8.4 gigahertz. The point that I want to make here, this was not just a Bell Labs proof of concept. This is realized by our mobile network business crew using commercial platform. And this is now being used for a field trial technical evaluation.
So if we need to update a wireless network every 10 years, as you suggest, 5G all the way back, and you've been working on 6G now for 5 years already, does that mean 6G will be as ubiquitous as 5G is today in 5 years?
Yes, that is indeed the goal. The history has shown it takes 10 years to prepare with the early research, go through the motions of the standardization, to get to the field trials. It takes to understand the requirements, get the feedback from the trials, the use cases, to get to a mature technology that you then can roll out. So yes, you're right. In 5 years from now, we can expect the rollout of 6G.
So if 5 years from now, how does 6G change business?
6G will enable to have a multiplication of business interactions. So in 5G, we can already get a very good sense of the digital world, the physical world in the digital world, apply AI to that. With 6G, we will be able to do it at scale and really allow multiple actors to leverage the infrastructure.
If 5 years from now, 6G is as ubiquitous as 5G is today, I can imagine that changes a society dramatically. What do you see happening 5 years from now, 10 years from now, and the role that our little glowing rectangles from these giant machines that you just held up from 1G all the way to basically what I've got on my wrist?
What I see happen in 5 years from now is a increased digital physical fusion, the fusion of digital and physical worlds. And that will allow us to have a better understanding of what's happening in the physical world and then anticipate possible needs and augment human capabilities. So
it's the beginning of the singularity.
In a positive way, the 5G already has these digital twins. In 6G, we will see that happen at a much larger scale. With the massive scale deployment of sensors that capture the world, the deployment of AI that creates an understanding of the world, the use of intuitive user interfaces, including XR, including gesture recognition, to then really leverage the network for new applications and augmenting our capabilities.
With the network effect in full effect, Nokia is helping unite 44 organizations to standardize interoperability for 6G. We'll see the first 6G release specification by 2028. And by 2030, with AI underpinning the technology so sensitive it can detect your blood pressure, you'll be using 6G in a heartbeat. Whether or not Captain Picard uses it to explore the final frontier remains to be seen. I'm Michael Hainsworth. This has been The Network Effect.